students, our next topic is derivatives of trigonometric functions. As you all know that we have done till derivatives by product and quotient rule, we are moving towards the new topic, that is derivatives of trigonometric functions. Let us suppose, let we take the function f of x equals to cos x. Now first we have to know that from where the derivatives comes till f of derivative of cos x is minus sin x. So for that we are doing the limit approach for solving this function, that is f of x is equals to cos x. Okay, what is the formula for the limit approach? That is f prime x is equals to limit h tends to 0 f of x plus h minus f of x divided by h. Okay, from here we can see that f of x plus h can be written in the form cos x plus h. Now we substitute all these values in this function, in this formula. F prime x is equals to limit h tends to 0 cos x plus h minus cos x divided by h. Okay, for this function, as you all know that this is a trigonometric identity. There is a formula cos x plus h or cos alpha plus beta, that is cos alpha cos beta minus sin alpha and sin beta. Here x is alpha and h is beta. Now we substitute this value here. That will become limit h tends to 0 cos x cos h minus sin x sin h minus cos x divided by h. See from here that there from cos x and cos x is common. So what we will do here, we will take this cos x common from both of them. That will become limit h tends to 0 and cos x cos h minus 1 minus sin x sin h divided by h. I can break this fraction h with this term and h with this term. That will become limit h tends to 0 cos x cos h minus 1 divided by h minus sin x sin h divided by h. I will apply this limit to both terms. That will be limit h tends to 0 cos x and cos h minus 1 divided by h minus limit h tends to 0 sin x sin h divided by h. See from here that we don't have to apply limit to this function and to this sin x, because this is the function of x and the limit is to h. So I can write it like this, that cos x limit h tends to 0 cos h minus 1 over h minus sin x and limit h tends to 0 sin h over h. If you remember that we have done these two limits in our previous chapter, in the chapter of limit, that this function is equals to 0 and this function is equals to 1. I will substitute this value over here, cos x and 0 minus sin x and 1. this whole term will become 0 and your answer is minus sine x.